All right. Can you hear me? Is that working? Yes, great. So usually this would be very interactive, but I've got 30 minutes to cover about an hour. So I'm going to talk very quickly. Sorry about that. I'm going to cover three things. We're going to talk about AI. Everybody's going to go away understanding what AI is and what AI isn't. There's a lot of misunderstanding about these technologies, and I'm going to give you a framework to understand what they are. We're going to talk about innovation, how we can bring people and technology together to do amazing things. And if we've got some time, I'll mix it up a bit, and we'll talk about the end of the world, which is always nice at the end of a conference as well. I do three things. I run a master's program in UCL. I have about 100 students every year that go out there and apply emerging technologies to solving problems across a whole range of businesses. So I've got a really good sense about where organizations are at in their digital transformation. I am the CEO of Satalia, and we build AI solutions for some of the biggest companies in the world. And I also travel the world educating people like you, business leaders, about the impact of technology on society. Before we get into definitions of AI, I want to gauge how intelligent this audience is. So I'm going to ask you a few questions. And the first question I want to ask you all is, what is data? I'm sure you've all heard the word data before. What is data? Huh? Information, not quite. Information's a little bit high up. Huh? Numbers? Yeah, good. It comes from the Latin word datum, which means given things. It's the fabric of our universe. It's bits and bytes. It's ones and zeros. It's not until you give it context does it become information. So if I say to you 210280, what is this? It's data. If I say that's a date of birth, then it becomes information. Okay, let's get you warmed up. What does this probably say? I know you can do this. Again, if you're normal, it says ABC. Okay, what does this probably say? Excellent. You can see that the data that's entering your eyes, the stuff in the middle, is the same data, but giving it a different meaning based on its context. And if I tweeted right now, my laptop is sick, what does that mean? My laptop is sick? Okay, good. You got kids? You're cool. So that sound, that data that's going into your ears can be interpreted in two ways. It can be very good or very bad. And if I asked you what this says, what does this say? John read the letter to Mary, or John read the letter to Mary. I want you to picture in your mind the scene, John read the letter to Mary. John read the letter to Mary. What picture do you have in your head? John read the letter to Mary. I know you can do this one as well, come on. Huh? John, a guy is reading a letter out loud to a girl. Okay, but John could be reading a letter that was sent to Mary or addressed to Mary. John could be reading a letter A, B, C, D to Mary. John could be reading the letter of the law to Mary. John could be reading a book called The Letter to a lady called Mary. John could be reading a book called The Letter to Mary. John could be reading 4 words on a piece of paper, the letter. This can be interpreted in many, many different ways, and we will all go away with a picture in our mind of what we think is correct and we're probably wrong. And my goal today is to convince you all that humans are rubbish. That's my goal today. But one of the biggest challenges we have in computer science is taking this stuff, this light, this sound, this text, and figuring out what does it actually mean. And we're getting quite good at this now. So if imagine if I give you a spreadsheet, and in the spreadsheet it has 3 columns. It has a column which is the date, a column which is the temperature on that date, and a column which is the number of ice creams that I sold on that date. So date, temperature, ice cream sales. Some of you are retailers, should be able to do this. What do you do with that information? Graph. So let's draw a graph. So we have along the bottom increasing temperature, along the y-axis increasing ice cream sales. What would our graph look like? I know you can do this one, wave your arms around. Good. We see some sort of trend going upwards. This is called descriptive analytics. What we're doing is we're organizing information to try to know things about the world. We know that as it gets hotter, we sell more ice creams. We can do something really cool now that everybody's excited about. We can do a thing called predictive analytics, and we can put a line through it. And we can do this very easily. And now we have predictive power. So if tomorrow is 22 degrees outside, I can look at my model and I can see how many ice creams I need to manufacture. And I can take this model and I can put it into a factory and now have my factory manufacturing ice creams based on this knowledge. But it's very different between knowing something and understanding something. So can anybody tell me why we sell ice creams when it's hot outside? Why do we sell ice creams when it's hot outside? I know you can do, and make money. I'm inside, it's hot outside. What's the first thing that usually happens in the UK? It rains. We go outside. Why do we go outside? Why do we go outside? Huh? We like the sun, but then what happens? We get hot, and then what happens? What do we do with the ice cream? Put it down our pants. What do we do with the ice cream? Huh? We eat it. And why does eating an ice cream cool you down? Thermodynamics, exactly. So to expect a computer to understand that narrative from this graph is impossible. It doesn't understand that we like to go outside and we like to get warm and cool ourselves down in different ways. It's really important to bridge the people that can understand the problem you're trying to solve with the people that are very good at finding patterns. So, because the person here, your domain expert, is going to say, Daniel, your model of the world's wrong. Because if tomorrow is scorching hot, tomorrow is the hottest day ever, what will my factory do according to my model? It's going to manufacture lots of ice creams. What will really happen if tomorrow is scorching hot? nobody's going to go outside because they can't reach an ice cream fast enough to cool them down. So the model of the world looks more like this. I would argue that what we're trying to do in machine learning and all this kind of stuff is understand the world perfectly so we can make good decisions. We can utilize our understanding of the world to make the best possible decisions. In this case, we want to manufacture the appropriate number of ice creams. It turns out that humans are terrible at making decisions. Let me try and argue this now. There's a book that I would highly recommend you all read called Thinking Fast and Slow by Daniel Kahneman. He says that we have a fast brain and a slow brain. So I'm going to try and test this brain now and ask you some maths questions. Right? They're going to start out really easy and we're going to get more and more complicated. So the first question is this. What is 2 times 2? Okay, what is 14 times 763? Okay, so the first one was your fast brain. The second one you need your slow brain for. Okay, the combined price of a bat and a ball is £1 and 10 pence. The bat is £1 more than the ball. How much is the ball? 10 pence. So you said 5 pence, you cheaters. You knew the answer already, didn't you? You did. So it's not 10 pence. If you said 10 pence, you're not broken. It's 5 pence. The bat is £1 and 5 pence. The ball is 5 pence. The combined price is £1 and 10 pence. I can give you lots of these examples, including the cheaters, and you will get them wrong. Okay? This is where you're using your fast brain. All right, imagine these are staff members. And what we want to do is we want to organize these staff members in a way that satisfies some rules. So the walking staff members have got to the right of swimming ones, and I don't know, you want to have tails next to tails. How many possible combinations are there of these 5 staff members? So looking at one combination, I can flip 2 around and get another combination. How many possible combinations are there? 5 factorial, 5 times 4 times 3 times 2 times 1. So there's 120 possible combinations. Some will satisfy the rules, some won't. Let's make the problem a bit more complicated. I've got 15 staff members. How many possible combinations are there? Don't say 15 factorial. What does your fast brain say? Huh? Huh? Too many. Okay, so there's over 1 trillion possible combinations. To expect a human to solve this problem, you're wasting your time. One rule to take away with you today, anything more than 7, don't use a human for. Okay? Any allocation of resources more than 7, humans are useless. Okay, and industry don't have problems of this size, they have problems of this size. So here are 500 Pokemon. Can anybody tell me how many possible combinations there are? No, it's a big number. So a number that looks like this, and just to put this number into context, this is how many atoms there are in the universe. Okay, so one of our clients is PwC. They have 5,000 staff members they're trying to allocate to projects. 5,000 factorial. Yeah, you can probably get a human to solve problems up to 7. You can build a nice algorithm that solves problems up to about 50. Anything beyond 50, you need to have deep, deep mathematical expertise in being able to solve these problems. And I'll come back to this in a moment. So let's just drum this problem home. I've got 24 points on a map that I need to make deliveries to. Humans are actually quite good at solving these spatial problems. So if we started at the bottom, maybe after a few minutes, we draw a nice path around those points to save the most amount of petrol. How long will it take a computer to get the answer, to get the shortest path? Seconds? Okay, so we played this game already. It's 20 billion years. If you put 24 times 23 times 22 times 20 into your calculator, you get this number. This is how many possible routes there are around those 24 points. And if you had a computer that could look at 1 million routes a second, that could process 1 million routes a second, it would take 20 billion years to go through every single possible one and say, this one that I looked at 10 billion years ago, this one's the shortest one, you should do that. And if I had another point to the map, I have 25 times 20 billion years, 5,000 billion years. If I had another point to the map, I've got 26 times 5,000 billion years. These are exponential problems. They get ugly very quickly. Tesco are delivering to 80,000 points on a map a day. 80,000 points. We have milliseconds between each customer coming in to be able to optimize those vehicles so we can show the best time slots back to those customers. These are incredibly hard mathematical problems, and even just a few percentages of improving of these problems can have a dramatic impact on a company. And the reason why I talk about this is because when we build solutions for companies, that we think about these 3 parts. Data. It's super, super important that you get access to data. And I know that lots of companies right now are bringing all of their data together, which is great. It's very difficult, but they're bringing all of their data so that they can do the next step. And the next step is to try and use machine learning, data science to extract patterns from that data, try and know things about the world. I know you're male, I know you're female, I know you're happy, I know you're sad. But once you've extracted those patterns, which is also very hard, you then need to make decisions. And decision-making is a field in computer science, often referred to as optimization. Maybe some people are old enough to remember operations researchers. Yeah, good. So operations research kind of peaked in academia about 2 decades ago. And what happened then is that everybody started to get excited about the middle part, machine learning. But I would argue that companies don't really have machine learning problems. They have optimization problems. They have decision problems. You use machine learning to know things about the world, so you can use that knowledge to make decisions. And if you build a system that takes in data, extracts an insight, and makes a decision, and tomorrow you give it the same data, it makes the same decision, what you have is automation. And automation is amazing because these things can do things way better than human beings. All right, but what is the definition of stupidity? Can anybody tell me the definition of stupidity? It's doing the same thing over again and expecting a different answer. The automation, by definition, is stupid. Okay? It doesn't mean to say that it's valueless. You can get a lot of value from automation. But for me, there are two definitions of AI. So the first definition, I think, is popular but weak, which is getting computers to do things that humans can do. Getting computers to do things that humans can do. The reason why this is popular is because over the past decade, we've managed to get machines to do things that traditionally were only in the domain of human beings. We now can get machines to understand natural language, to be able to know you're male, you're female, that's a chair. We can start to get machines to do things that only humans used to be able to do. And because humans are the most intelligent thing we know in the universe, we then assume that that's intelligence. I would argue that humans are very good at finding patterns in about 4 dimensions. Computers can find patterns in thousands of dimensions, and humans are very good at solving problems up to 7. Computers can solve problems with thousands of moving parts. So benchmarking machines against humans is a very silly thing to do. We can build machines that can significantly outperform humans. The better definition of intelligence for me is this one. So AI comes from this one. It's goal-directed adaptive behavior. Goal-directed in the sense you're trying to achieve a goal. You're trying to solve a problem. And very often when we're engaging with companies, they don't know what the problem is that they're solving. What is the goal? What is the objective? Behavior is how quickly can I move towards that goal? How quickly can I allocate my resources to achieve that goal? But the key word in this definition for me is adaptive. If you build a system that makes a decision, learns about whether that decision was good or bad so that tomorrow it can make a better decision, I would argue that it's AI. And if I was being brutally honest, I haven't seen a single successful, complex adaptive system in production in my life. So everybody out there that's saying they're doing AI, I would argue that they're not. So does anybody remember the Microsoft Twitter bot that became sexist and racist very quickly? Microsoft launched a bot on Twitter. Lots of teenagers decided to tease it and became a Nazi bot very quickly. This is what happens when you put systems in production that adapt. And if you say to an IT person, we're going to put a system in production that's going to behave differently today than it will tomorrow, they say, no way is that going into production. And if you say, we're going to put a system into production that it needs to make mistakes to get better, they say, no way am I putting a system in production that I'm going to admit that is making mistakes, even though automation is making mistakes all the time. Building adaptive systems is the true paradigm of AI, and it's incredibly hard. So there are 2 flavors of AI. This is Socrates before he drinks hemlock, and Socrates is famous for inspiring the Socratic method. So if, for example, you know that Mary works from 9 till 5, and you know that Mary works away from her home for her job, and you know that her delivery slot is 9 till 5, you can infer that Mary won't be home. So AI in the 70s and 80s was writing down lots of rules and trying to infer new knowledge from that system. It didn't really scale, it didn't really work. And then in the 80s and 90s, a new type of AI came along. This is the brain of a bumblebee. Bumblebees have 1 million neurons. Their brain can fit on the end of a needle, tiny, tiny brains. Bumblebees can do amazing things. They navigate 3D worlds, they talk to each other, they solve problems. They don't handle Windows very well, but ultimately, they're very smart creatures. And the question was, can you take the power, the brain of a bumblebee, and put it into a machine, and have a machine navigating 3D worlds and solving problems? When I was doing my PhD 15 years ago trying to model bumblebee brains, it was impossible. But 10 years ago, what happened is that a new paradigm in this technology meant that we can now build brains that have hundreds of millions of neurons. We can now teach these brains to do things that only human beings used to be able to do. Okay? Now, I would argue that these brains, often referred to as deep learning or neural nets, some of you might have heard of that, these brains are really good at finding patterns from data. They're really good at knowing things about the world, but you would not use these brains to make decisions. Ultimately, you want to use these brains to know things about the world, how long it's going to take to deliver to this customer, etc. Then you want to use this type of technology to then reason and optimize and make decisions. The challenge is how you combine both and build a system that adapts itself. It's a really difficult problem. Okay, so this is where it gets a bit weird. So if this is the bounds of human endeavor, this semicircle, I would argue that we could probably take any specific thing that we can do as a human being, and we can build a system that can outperform us, whether it's recognizing patterns in images or whatever. But it's very inefficient to build individual systems to solve individual problems. So there's an interesting area of research called artificial general intelligence. You are all GI. You are one system that can do many things. So the question is, can we build a machine that can do many things instead of just one thing? And if you take this to its logical extreme, it's predicted that within our lifetime, we are going to build a brain that is smarter than us in every single possible way. It is the last invention that humanity will create, and some people think it's going to be the most glorious thing that happens to us. Others think it's going to be our biggest existential threat. Okay, I think it's our biggest existential threat, and we're trying to figure out how do we solve this problem. Actually, if you ask Elon Musk and people like that, they will say, actually, Daniel, this superintelligence thing has already happened. There's a concept called the Fermi paradox, which is that if you look at the size and the age of the universe is very big and it's very old. The mathematical likelihood of there being intelligent life in our universe is mathematically very high. The mathematical likelihood of that intelligent life reaching a point where it builds a superintelligence, like we will in the next 30 years, is also very high. So if you build a superintelligence, if you build an AI that can travel space and travel time, then in theory, when we look into the night sky, we should see a universe teeming with life. We should see evidence of life. And the hypothesis is that actually, the reason why we don't is because we're living in a simulation created by a superintelligence in a different universe. So there's a 1 in a billion chance. You need a drink now for this. There's a 1 in a billion chance that this is not a simulation. There's some interesting experiments in quantum mechanics that suggest that this is a simulation. Anyway, before we, this is called simulation theory. Before we build a superintelligence, we're having to build systems that make decisions about our everyday lives. I'm sure you've all heard of this problem before. It's called the trolley problem. So I'm in my driverless car. In front of me is a kid. To the right are 2 adults. To the left is a cliff. And they can only kill one. So who would kill a kid? Nobody. Who would kill the 2 adults? Nobody. Who would kill you? Oh, a few people. Okay. But for 3,000 years, philosophers have been pontificating about this, and only now are we having to build systems that are answering these questions, which for me is super exciting because we're having to build ethics into our system. So if there's a burning building, and in the burning building there's a crying baby in a suitcase with £1 billion, what do you save? You can only save one? Huh? Huh? So a suitcase and a baby in a suitcase. The suitcase is not on fire yet. Yeah. So most people say they'll save the baby, but actually, if you save the suitcase, you can save a lot more babies with £1 billion. And not that I would save the suitcase, but if you build a robot and you say, robot, your objective, your goal is to maximize life expectancy, the robot's going to go and save the £1 billion because it can invest in curing malaria and all this kind of stuff. And you'll probably know the answer to this, but if I built a robot and say, robot, your objective is to eradicate cancer, what is the easiest way of eradicating cancer? Eradicating humans, exactly. So we have to be very careful, not only about the objective that we give robots, but also the constraints that we give it as well. These are optimization problems. And there's a whole world of interesting stuff around this, around explainable algorithms, explainable AI, that I would love to get into, but I'm going to have to move on. But explaining algorithms and how they make decisions is incredibly complicated. And I would argue there are only a handful of companies in the world that know how to do that. It's going to become more and more important over the next decade. So let's switch to innovation. I just want you to take a moment and look at this graph, this diagram. I'm sure you don't have problems like this in your company, by the way. And this is not a picture of Satalia, although I do know that most people sell drugs to each other at the bottom there. It's very common. This is a hierarchy, and hierarchies breed certain types of interesting relationships. And I would argue that this structure is not conducive for innovation. Okay, so in fact, I would argue that this technology that I've just described will become a commodity over the next decade. So we already have access to lots of free computing. We have access to lots of data. We have access to all of the tools you need to be able to create chatbots and big brains. They're all free. It's all open source. At some point, somebody will commoditize optimization, and somebody will commoditize self-adaption. The big battleground for companies is not technology. It is talent. How do you attract, motivate, talent to be able to come up with innovations? Because if your company is not innovating, if it's not adapting to a changing world, it's less intelligent than another company, and you will fail. There's actually, Steve Jobs had a really great definition of innovation. He said, innovation is creativity that ships. And the most important word for me in that definition is the word that. That is taking ideas and getting them to a point where somebody's willing to pay for them. And that is a painful process. The goal of your organization is to shorten that process. So we think that we're inspired by this book by Dan Pink. He said there are 3 things that motivate people: autonomy, mastery, and purpose. So autonomy is giving people the freedom to do what they want. Mastery is giving them the ability to become really good at what they want to do. And purpose is giving them something higher to align themselves with. And this purpose thing is going to become more and more important. But your first challenge as a company is to be honest with yourself and ask yourselves, where am I on this diagram? So how sexy is my brand or industry, and how interesting or challenging are my problems? Because if you're not sexy and you don't have interesting problems, you're not going to attract talent. If you're sexy and you've got interesting problems, you'll attract talent and they will stick. And if you're in the other two quadrants, you'll attract talent and they'll churn, they'll leave after a few years. So this will determine whether you build out your own AI team, whether you work with third-party vendors, suppliers, etc. The number of CEOs that I know that have created a pot of money to build an AI team, and they can't hire a single person because they're deficient in this diagram. So once you've attracted talent, the next challenge is how do you create a culture that enables that talent to adapt, to thrive? Because if you're not adapting, you're not intelligent. And over the years, we've seen the flattening of organization using new communication technologies like Slack and this kind of stuff has allowed us to flatten these organizations to remove middle managers. And I would argue that this structure is still broken. So Satalia only has about 100 people right now, but we have no managers, no hierarchies, no KPIs. Everybody's free to work where they want, how they want, on whatever they want. We use technology to try and operate like a swarm. And my goal is not just to scale that to 1,000 people or 10,000 people. My goal, it's going to sound crazy, is to scale it to a planet. How can we create a planet where everybody is free to be able to work on whatever they want, however they want, wherever they want, and be remunerated for that contribution? Many of you are currently going through your digital transformation, getting all your data together, which is incredibly important. And the next phase of your digital transformation is actually creating digital twins of your company. You're putting IoT devices on your assets to try and understand the health of your machinery. Eventually, you will have devices on all of your employees trying to understand their well-being and this kind of stuff. In fact, this is a digital twin of Satalia, so I can see that if one of these two people leave the company, I'll have a silo between two parts of my organization. I can identify secret lovers in my company. I can identify people who are going to leave before they know they're going to leave. There's lots of interesting ethical questions around this, but by having a digital twin, it will allow you to ask questions and adapt your organization to a changing world. Maybe I'll leave this to one side, but just to comment on this, what was interesting, it turns out that females tend to undervalue themselves. And we ask everybody every year to make public recommendations for their salary. So you would all make public recommendations for your salary, and then everybody else would vote on whether those salaries should be reduced or increased or kept the same. And we use machine learning to determine how many votes one person has for another. So if I've worked very closely with you over the past year, if I'm very knowledgeable about your domain, I will have more votes for your salary. And this is how organizations are starting to be restructured, to distribute decentralized decision-making, to allow them to make better decisions and to adapt more quickly to a changing world. And one of the examples here is how one of our females were consistently asked by the organization to increase her pay. I won't go into. So let's talk about the end of the world. So AI has probably had the biggest hype of any technology that I know. It's bigger than big data. It's bigger than innovation. And I think that we're going to start to feel the results of that hype. But I also think that it's also going to have perhaps the biggest impact on the world. So once we get through this current hype, we're going to realize actually the importance of these technologies. And we're seeing governments investing heavily in building AI. We're seeing companies investing heavily also in AI. And I don't know if anybody knows where that quote came from at the top. Can anybody tell me who said that? So the nation that leads AI will be the ruler of the world. It was Putin. So Putin said it to a group of kids, I think it was, which is quite weird. But I think the acknowledgement is that these technologies are incredibly important and they're not going to go away. So I'm a little bit worried about the future. I'm a little bit worried about the impact of technology on our society. And I don't know if anybody has watched the series Black Mirror on Netflix. I'd highly recommend that you watch this series. Each episode is a dystopian future where technology has kind of gone awry. And this particular episode here is called Nosedive, where we're living in a world where we have an app and we're rating each other on the app. So I'll be rating you now for not answering your questions correctly, and you'll be rating me now for speaking too quickly. And what happens is that creates a score that you carry around with you, and that score unlocks faster internet and better hotel rooms and this kind of stuff. Now, this is being rolled out across China. We know this. We think it probably won't happen here in the West. It is. It's going to roll out across the West. And my concern is that the organizations or the people that determine what is good and what is bad, they're the ones that are going to be able to rule the world. And I think that there are some ways of solving this problem. So let me try to give an example. And I think this is really important to think about from your perspective in business. But Facebook is an easy target to point to right now. But what is Facebook's primary objective? What's their primary goal? Huh? Users. For what reason? Make money. So I would argue that their primary goal is to make money. And they've got an army of PhDs whose job it is to keep you looking at that screen. The longer you look at the screen, the more money they make. And I know who's going to win that battle. It's either Facebook's army or your kids. And the challenge is that when you can't innovate, when you can't create new ideas that create new value, what tends to happen is to provide your 5% returns to your shareholders, you end up making bad decisions. You make decisions that compromise the environment, compromise your employees, compromise other species. And I think that we need to completely rethink this model of the world. And actually, I would argue that if you can build a platform that can bring people together from all around the world to be able to build an open source version of Facebook and have those people remunerated for their contribution, you don't need to have centralized companies anymore. And we actually are moving towards this model of decentralizing or open sourcing many of our technologies to commoditize them. And I would argue that you might be sitting on some innovations now that if you're not continuously investing in, if you're not building out those innovations, some of your competitors are going to come along and they're going to open source. And they're going to access a community of talent that can be remunerated for their contribution. And they're going to get there first. They're going to have access to data, and they're going to have access to the talent. So I would really think about how you could take some of your innovations and figure out how can we build a community around driving these innovations forwards. And I think this is where industry is going to go over the next decade. So there's two things I'm concerned about. I say there's three things up there, but there are two things that I'm really concerned about, which I think actually I'm still optimistic about. One is called the economic singularity. So you might have seen in the press the concern that AI is going to take all of our jobs. Now, at the moment, AI is creating a huge amount of value. It's enabling people to be freed up from the mundane tasks that we're rubbish at, solving problems bigger than 7 and things like that. And, but there is a concern that in the next 15 years, people will be freed up from their jobs, and we won't be able to retrain fast enough to get new jobs. I sit in a number of think tanks trying to figure out how to solve this problem, so I know there's lots of very clever people trying to sort this out, but it is a concern. The second concern I have is what is called the technological singularity, where we build a superintelligence smarter than us in every single possible way. And it will be the last invention we create. And I think the best way of making sure that we're not going to be wiped out by this thing is by getting humanity to a point where we are collaborating together instead of competing. If this thing comes along and we're still competing with each other over resources, it probably will remove us from the planet. And I don't expect governments to solve this problem. I actually think that the solution is going to come from the private sector. So companies now, for them to survive, I think they need to have not just great products, but they also have to have a strong purpose. For you to be able to attract customers, for you to be able to attract contributors, employees, it's imperative that you have a strong purpose. Satalia's purpose is to enable a world where everybody can do what they want. And I would argue that if you're not having that strong purpose, you're probably losing talent and not replenishing it. So I will close there, I think, and say goodbye.